Okay, so we had a question about problem 12 from the week 2 assignment, how to kind of visualize these problems. So to be able to do this, well, we're going to look at part A, and each part is asked about the shape of the distribution, the typical observation, and the variability. It'll help, especially to answer the first part, the shape of the distribution, to draw a bar graph. So I'm going to look at part A, and this might be a little bit difficult to visualize, but what you want to do is to draw the values from smallest to largest, and um, and make sure you go in equal increments, because that will really help to build the distribution. So um, you'll see what I mean. So we have 20%, 25% of the houses cost below $350,000. So we're at $350,000, and we have 25% of the houses. So we're at $350,000. So let's just kind of draw a timeline. So notice that the highest percentage, 75% of the houses cost below $1 million. So we have $1 million, $6 million. So let's just say this is 6 million. And then right in the middle we'll have 3 million. That's what I meant by equal increments. So we want to make the values equally spread out. So 1 million would be about right here. And this would be 0, which isn't practical. You don't have any houses that are 0, unless you just don't own a house, which, well, whatever. So 350,000 would be about right here. And then 450,000 would be about right here. Okay, so notice that 25% of the houses cost below 350,000. So 25% of all the houses are going to be down in this area. So we're going to have a lot of your data up in here. So if we're kind of building a bar graph. So 25% of your values are right here. And then it says, and then it says 50% of the houses cost below 450,000. So that includes, below 350,000 also. So I mean, so that's telling you between 450,000 and 350,000, we have 25% in between those two, because we already have 25% below 350,000. So that leaves from the 50%, 25% in between here and here. So actually, that's going to give you a bigger bar, because we have a smaller interval between here and here and here and here. So even though both of these represent 25%, the width makes a difference. So it's a skinnier width, so we need a taller bar to represent 25%. Okay, so and then 75% of the houses cost below 1 million. So keep in mind that we've already have 50. This is 50% already. And then we have 25% that are in between 1 million and 450,000. So this is a wider interval. This is a wider interval than both of these. So actually, so that's 25% is left from between these two intervals, because we already have 50% here. So it's 25%. So this is the widest interval. So even though it's 25% still, it's going to be a smaller interval like this. I mean, this is getting into real in-depth detail. And then above 1 million, and then there are so there's a meaningful number of houses that cost more than 6 million, but that only leaves 25% in between 1 million and 6 million and beyond. So it's actually going to be pretty thin. It's going to end up getting pretty thin over here, but there's not going to be that many. So anyways, to determine this, so this is the shape. You should be able to tell what the shape is. look at this humongous tail. This is, so it's just a general graph of this. We're looking at a shape that looks like that. And this is, you know, really big, right skewed. I mean, you didn't have to go into this sort of detail, but I mean, this is a pretty well detailed graph. Just to kind of understand how to break this down. Not all the different parts are like this, but you can break it down like this. And if you're just skimming through this information, you should be able to tell that most of the information is on the left side of the graph, and then not so many on the right side. So that's right skewed. Anyways, but from this, we can see that you know, the extremely expensive houses, just because it's right skewed, I mean, that tells you the first part of the question. Just because it's skewed doesn't mean that it's will tell you the answer to median or mean. You have to look at more information in the problem. So there's some extreme values that are big time outliers. So we need to figure out, are there outliers in this sort of area, in the tail of the data? So not all right skewed data has outliers. Some do. So if there are outliers, then you should use the median. So if there are outliers, then you need to use median. If there are no outliers, I mean, it won't directly say this in the problem. As you can see, it doesn't say that here. But you can tell that there are outliers in this data, because there says that there's, you know, there's houses in the 6 million beyond range, which are going to be huge outliers compared to the bulk of the data, which is, you know, below 1 million. So keep that in mind. If there are no outliers, you use mean. And then similarly, you'll determine IQR versus standard deviation. If you're using if there's any outliers, then you'll use IQR. And if there are no outliers, then you will use standard deviation. Standard deviation, DV. Okay, so that's how you break down your thought process and determining the results. This, I mean, depending on the student, this can be pretty challenging to visualize graphs, but it's a huge hurdle that you'll have to get over in this class, because a lot of this is word problems and being able to visualize the data and pull information out of the word problems. Okay, so let me know if you have any other concerns. Hopefully this helps, and yeah, be more than happy to help if you have any other further concerns.